So welcome everyone. My name is Victor, and I work at CSCS, the Supercomputing Center on Switzerland, and I'm part of the user engagement team and scientific support team. So I am a PhD in chemistry, so I'm a guy that does the support for scientific applications, and we care a lot about guaranteeing that scientific applications are running perfectly in our system. So for that, CSCS spends a lot of time and money on getting regression testing of our scientific applications, right? So before I actually talk about what's ReFrame and what we have done as a tool, as a framework to guarantee this quality of service for the applications that we run in our systems, I want to give you a bit of the background, what was before at CSCS before we started ReFrame. So CSCS had, by the time, very monolithic script that would do all the testing of applications through shell scripting. So we had a huge, it was well written for sure, but it's a bit difficult to maintain scientific software in shell and the testing. So we wanted, one day they decided to change the scheduler on Cray from API to what was again AP run to Slurm, native Slurm, and then we had to change a lot of lines inside of shell scripting. So it was a bit maintenance hell to change, and if there was a bug in one script because we saw, oh, we are checking the way that we're doing the testing is a bit wrong, we had to change it, and we had to go to all of the tests and do again. So it was a bit of tedious task and difficult to handle. So then we came up with a new solution that's called ReFrame. And ReFrame is basically based on Python. So it's a framework that we want to leverage all the software, scientific software methodology. So I like OOP, right, object-oriented programming, and also the fact that we had to change the scheduler lines from all our tests. We start to say, you know what? I think we should be abstracting away the system, abstracting away the module systems, abstracting away a lot of things, so we can actually focus on only our tests, right? We should not be focused on details of the system. And we do support different systems that are like conventional Linux boxes or into Cray systems, so highly customable systems into basic ones or generic ones, standard ones. So it's a bit difficult to actually maintain, and if you don't abstract away the system in your regression suite, right? So we want, as ReFrame, the user to be focused only on the logic. So if I want to write a test for GROMACS, for instance, I want to be focused on my GROMACS run. I don't want to be caring about how the job will be scheduled, how it will run the system, which partition it will run. I really don't have to care much how to submit to that partition. I just want to say, I have a GROMACS at GPU, I want to run a GPU partition of PITSTINE. If I don't have if I have CPU only version, I want to run on the CPU partition of PITSTINE. That's it. I don't want to say how I can achieve that partitions, right? So we started ReFrame. ReFrame starts to get momentum, and starts to be developed in March 2016. Now we are on release 2.16, and we have like 18 forks and 32 stargazers, and still counting, right? It's a bit difficult. I updated the numbers a bit before because it was 31 in my slide. Now I have 32, so it's all the time changing. And the reason why I like so much the ReFrame is actually the design goals, right? That's what drives me crazy or amazing design goals we have. The first one is productivity. As a chemist, right, I want to write my test as productive as possible. I don't really want to care about all these details of computer science. I want to be really, really fast on writing my tests, and I want to run them as fast as possible. So, and I also don't want to care much about the system, right? Am I running Slurm? Am I running PBS? Why do I have to care? Why do I have to care if I'm running L mode or running T mode or T mode 4? What are the details? I don't really care much about these details too. So for me, I was hired at CSCS, and for the first week I got the task to write tests on ReFrame, and then I started to write them, and was really, really fast to start using it. And I could, like, in the first 2 weeks, I think I wrote like 132 tests. Was really, really fast. So that's what I really like about it. It's really fast to use, it's really fast to integrate. And from that time, it's we have been run ReFrame daily. We run ReFrame daily in our productions. We have never seen any, let's say, stack trace of ReFrame. ReFrame is very robust, right? So we have a very well-written code. The design is really well done, and it's the team lead for the design is Vasilis, and he's really keen on guaranteeing that we have a good code for ReFrame. So what does ReFrame as a framework support, right? The first thing that also Kenneth was talking about, EasyBuilds, that we do not have Python dependencies, right? I mean, we have no external dependencies on Python. Just if you have a bare Python, you can run ReFrame. Of course, it's Python 3 based, so you do have to have a Python 3 installations. So if you want to run a unit test, of course, you have to install something for the unit test as PyTest. But if you don't want to run a unit test, you can have your Python and start running it. So it's really good to have that. And for the way that we, as a perspective of the user who is writing the test, we have complete separation between what is a system, what's a program environment, and your test, the logic. So we're gonna see the API. I'm gonna show you later how we're gonna do the division, and this thing makes your life very easy, because then if the user doesn't have to care about that, then the user just writes I want to run a program environment GNU, which means I want to run in GCC, and I want to run with Slurm, and then my life is done. So I'm going to load the appropriate GCC compiler and then run with Slurm. Of course, that requires some logic inside the framework. So we take all the pain for guaranteeing that inside the framework, and then you have to tell us what does it mean to have the program environment GNU, right? Where you can find the module, what's the module for that. So that is also, a user has to configure it. So it's not something that you download and you start using it as was, but you have to get, for your system, you have to set up some let's say, mapping between the system and what we expect, right? So we do have some sort of cycling. So I can say my test for Gromax, if I have Gromax installed with GNU, Intel, PGI, Cray, I can go and say, I have this test, and I say I support these program environments, GNU, blah 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 blah, and then ReFrame will automatically generate different tests for all of these. So you're gonna cycle through all the program environments and generate tests, and I can test all these installations of independent installations of Gromax, for instance. And then the fact that we not having like some JSON file to define your test, but we leverage Python, it means that you can be really clever on how you generate the test. So you can leverage the entire Python infrastructure to do that. So this allows us to do some easy customization, so you can have really easy factory designs, or you can spawn a lot of tests, and you can also do a lot of flexibility in organizing them, because you can have a hierarchy of tests and all this kind of stuff. For us, on the user support perspective of ReFrame vocabulary, let's say, we do have something that's called sanity checking and performance checking, right? So when we talk about, in general, to the operations people, when they say, oh, the system is sane, for them the system is sane means the system is producing correct results and is performing correctly. In ReFrame perspective, if the test is sane, it means that the test is producing correct results, and if the test is performant, it means that the test is getting the correct expected performance on that system, right? So we do have this separation, and then there we allow the user to customize the way they extract what is sane for them and what is performant for them, right? So if I have my code like CP2K that gives you time as your measure of how much it will run, so I can go there and look at for the time. If I have Gromax that gives you nanoseconds per day, for instance, I can go there and look at the nanoseconds per day. So you have this flexibility of looking what does performance means for your test. For instance, like we have a Hello World application, I can actually see the performance. What does performance mean if you're compiling Hello World, right? It's the time taken to compile Hello World, for instance. We can decide you can decide yourself as the guy writing the test, what's the logic, right? What's the real thing that you mean by performant? And when you run ReFrame it, you can easily see the progress, actually happening. So you see what is, I'm going to show you later, what is being running. You're going to get the performance progress of your test, and also you're going to get summary, what failed, what we didn't fail, what passed and we didn't pass. And by us, failing means you either failed the sanity or you either failed the performance, right? So that's our concept. So we're gonna see at the end of the test of ReFrame the summary what has failed. We also have an amazing login support. So it's incredible. You just like write, you configure to say I want to be a file, or I want to print it to the extrude, or I want to do Graylog, and then it just works. So you're gonna send your files to Graylog, you're gonna write the file, you're gonna print the screen. It's gonna be boom. Yeah. So it's amazing though, the way we have done that. It's really nice. And then we have that's one of the things that I like a lot to work in the internals of ReFrame, is that we have a really clean API. So, and we tend to make the API very stable, so to guarantee that we don't do a lot of changes, but we keep adding functionalities. Another thing we do is basically currently we support Slurm and PBS, but ReFrame is an open source project. You feel free to contribute to other schedulers if you like. We will love to increase this list. We also have support for different launchers, so srun, MPI run, MPI exec. We also support no launcher. You can run your code directly without any launcher. We already support tmod 4, lmod, and tmod. So any environment tools available on the market, we do support. So we are ready. We have like build systems, backends, CMake, AutoTools, and Make. We're also planning to do EasyBuild and SPAC build system, but we didn't do that yet because we need to figure out better the use cases. So we want to guarantee that we are covering as much use cases as possible in a simpler way. Because on ReFrame, we do care about the user's story, right? We're gonna see the test, and for us, it's all about writing the test. If the test is becoming difficult to write, that's not a good design. So we go back and then we redraw again and redraw again, redraw again until you get a really easy to use for the user to write tests, right? Because as we had heard before or yesterday, someone said, well, I'm not really good on Python. That's what we want to guarantee here, that you don't need to know a lot of Python, just need to know the basics. You can copy a basic template and changes slightly small things, and you get your test, because you want to guarantee that everyone from sysadmins who are not really comfortable with Python to computer scientists who are developing their code and want to do CI with them can do with ReFrame. So we have asynchronous execution of tests, which means that we take the test, we submit a lot of tests to the queue up to a certain amount if you want, or you can say that the amount is infinite, and you can submit everything to the scheduler, and when it finishes, we're going to reprocess. So it's a really good way of making use of the scheduler to submit different jobs and doing parallel executions of the jobs. And we claim, like the OpenHPC people, that we have an extensive documentation. So I think we have covered everything. And Vasilis is really, how can I say, tough on that. So we never make a release if the feature that we want is not documented. If the feature is not documented, we don't have a release. So, and we want to have releases because we have the bosses asking for releases, so we had to write documentation together with the feature. So I would say that a majority of all the features actually are covered by the documentation in ReFrame. So we have many more things that we support. Please take a look at the GitHub. The project is an open source project. Anyone can contribute. So how do we envision this architecture? How can you abstract away all these? So we have clearly defined a regression API. So what's the user who's writing the test sees, right? And we also have seen a front-end API. So that, let's say the people who are actually running that, right? Running the ReFrame. Because on CSCS we have this separation. We have the separation of people who are actually writing the tests, people from the support in general, and people who are running the tests on maintenance, for instance, are the people from operations, sysadmin. So we have these two classes of people, right? The green people, they basically just have to care about the front-end flags, and in general we try to make a very simple interface for the command line. Just do -r and it's running. If you do -l, you list the tests. So it's really simple. You can do -h, get the help. So where we support a lot of command lines. So we try to get the grooming people really keep smiling then. And then for the guys who actually developing the test, that means me, right? We want that they write as less code as possible and be as expressive as possible. So we take advantage of many abstractions from Python, and also in practice what I have to do to write my test is write a simple Python class inheriting from regression test, and after that I already have my test. So I can customize it to get actually what I want, the modules that I want, the programming that I want. If I have to compile, what is the source code? If I want to get a makefile, what's the makefile? So I can customize it, and then voila, it just compiles, submits, and runs your test. You can analyze it, the standard in performance. I'm gonna show you later how it looks like. So here, the writer sees this thing, right? So we have an API that will allow you to have some system abstractions and some environment abstractions, right? And what you call system abstractions is basically the schedulers and the launchers, right? So this is related to the system itself. And the environment abstractions is the module system and the build system. By the build system is like make, CMake, environment modules we mean by the tmod and mod. So we don't, you will have access to these abstractions, but you don't really have to how can I say, define if I'm going to be PBS or not, or really go deep into the API. So it's a bit packed. In general, it doesn't look like so packed. I have to cut the lines, I mean to remove some lines to make it fit in the slide. But this is, as I told you, you just like mark some, you decorate the test, your class, Python class, and you inherit from regression test. It means that you have a simple test. You can change this to, actually I'm going to show in the next slide, to get a factory of tests, so you can spawn several tests. And then basically you get a description. You say, I want to run on the GPU partition of Pitstein. And then I can say, I want to run this test with GNU, Cray, and PGI. So I'm going to compile my CUDA code, because it's .cu right here, with these 3 compilers. And ReFrame automatically detects that this is a CU, right, a CUDA. So we're going to call NVCC on this. And then we're going to say the system is the build system single source. We're going to take this single source, take the flag. I'm going to execute the code with these parameters. So with the executable with 4096 and 1000. I have to load CUDA toolkit on Pitstein to have access to CUDA. And then I can say the number of GPUs per node. I can get the patterns. So I'm looking at the output of the program on the screen to say time for single. If I have this thing, it meant that it has passed. The performance is get the performance in gigaflops, and then I can say I'm expecting 50 on that case. So I'm expecting 50 gigaflops for that particular application. Of course, this number is just like a dummy number that we're given here, right? And we also have allows you to, we added some other things to guarantee the maintainability, or let's say the usage and report of problems. So we have a maintainers list, so you can put your name here. So whenever you get a failure, in the report you say, hey, please contact blah 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 blah, and then you can put your stuff here. So you're gonna contact the people. So we also have what's called tags, because on CSCS we do write tests for different setups. So we do tests for production cases, so we run daily. We have maintenance tests, so we run during maintenance, before and after maintenance. And we also have diagnostics, so when a node goes bad, we're gonna run this test to guarantee that the node is back, it's in a sane state. So this is a really simple case, but this a real case where we have the code called Arbor. That's also a code that's developed at CSCS. That's neural network analysis. And this test requires CMake, so you can write CMake and you give some parameters for CMake, and then you're going to compile the code and run the code. But because this code actually has different compilation conditions, so you can do a serial code, MPI code, blah 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 blah. You can actually import from the base test the MPI version of the code, and then you basically just say, you add the missing flag for CMake, and then what's going to happen? You're going to take advantage of the entire OO or inheritance, right, from Python, and you're going to get a new test that leverage the base test. So you're going to have two tests now, one with MPI, one without MPI. And of course, we can do better. I mean, we can do way more than that. So we can actually have different compilations of different architectures. So we can have Haswell, Broadwell, native, and you can start to parameterize this test and do other options. So if you want to run different conditions or different cases, so I can go there and leverage basically a factory. So I don't have even to write a factory class or a fake factory function to spawn different tests, because I can just basically parameterize my test, right? So this actually, it may look like, yeah, that's a bit silly, but in fact, when you have a lot of tests and you want to spawn different cases, instead of writing a function that's pretty big, but just giving like one line, saves a lot of space and drops a lot of the maintenance costs, right? So, but really, I wrote this, but how does it really works, right? It makes no sense. I mean, it cannot be magic, right? So on ReFrame, we do something like EasyBuild does. We have a pipeline. So we go through a set of steps that's always the same. So when you start the framework, you're going to basically get all the tests from, going to import all the tests, like EasyBuild does, imports all the easy blocks, right? And then you're going to start running the tests. And then you pick one test, and then you check, is this test supported by this environment or not, of this system or not? If it's not supported, then you're going to pick the next one. You're going to continue, right? Because you can say, I am PITS-9 as before, the test, but I can be running on my laptop. If I'm running on my laptop, it's not PITS-9. So that test was written for PITS-9 will be skipped, right? So, and then you can look at the program environments that are installed in your system and also available for your test. Then you go for a setup phase. What does it mean? It means that we create the folders required to run the test. We clone the environment to guarantee that we can reproduce the environment of the test. Then we compile if it's necessary to be compiled, and then we run. It can be asynchronous, as I told you, can be running parallel, taking leverage of the scheduler, or not. If you want to run serially, you can also run serially. Then we do the sanity checking to guarantee the sanity, the performance, and then you basically, if you pass or not, you just clean the results. And then finishes, you go to the next step, and then you continue, right? So the pipeline is given, like in EasyBuild. So the one thing that we have defined for this pipeline, and the idea of the pipeline is to get how can I say reproducible run, right? So we can actually guarantee that whenever you run, you're gonna pass by all those steps, and you can define what actions you can take on those steps. But sometimes you really don't need to go through that, right? I have compiled GROMACS, I provide GROMACS on the system. Why do I have to compile again, right? So I can skip the compile test. So we have done some how can I say, help the users to skip this pass. So we have provided two other classes, a compile only test or run only test, that you can compile the test only, like hello world, if you want just to compile and to guarantee that it produce binaries, or you can run the test like GROMACS, just run application because you have compiled already with EasyBuild, for instance. So another thing that we allow, because we're doing Python, right? Users can do anything. We can allow the users to overwrite anything we have done, right? So you can go there and overwrite the setup class and do something different, and then play around with other setups. So it's just like, before my test was not working, I didn't go there, overwrite the setup, do something different because I want to do something, and then it just works, right? So that's you can do these how can I say, customizations as much as you want, right? So by that we actually cover all the possibilities of tests that we have on our regression suite. We have never encountered a condition that we could not write. Of course, we have encountered conditions that writing the test was not that good, so then we worked out the framework to allow us to better deal with these cases. So if you're writing regression tests and you are thinking that it's being difficult, share with us your tests. Maybe it's a missing feature that we have to support on ReFrame, right? So I was just going to jump the front end stage, but running the front end is more or less like that. You just run this ReFrame and -R to guarantee that you're actually running the regression, and you can customize your configuration, which this configuration is the map between the system that you are running and your tests. So I can say, oh, PitchDyn has Tmod installed, so I'm going to run Tmod. Oh, my laptop has Lmod installed, so I'm going to run Lmod on my laptop. So this is that's the mapping between the system. Oh, my laptop, I have Clang, LLVM, and GNU. On PitchDyn, I have Intel, PGI, all those. So this is the mapping. And this is maybe saying, oh, this is a bit silly, but actually this allows me to write my tests from my laptop through a Travis CI to Jenkins to PitchDyn. I can bring my tests from all these systems because I can actually just add to this path, right? Just add to this folder. And I can take my test that runs on PitchDyn and I start to run on Juby, no, so on the Ulish systems, right? And then I can take my test and start running on Exit systems. So just by adding this map file, right? Of course, when I'm writing my tests at CSCS, they do have this Dyn, GPU, Dyn, MC, the program environment from there. So going from my program environment from Cray to a different Linux box is not, doesn't make much sense, right? So my tests are not sometimes Cray specific, right? So I can also change the path of the folders that I have my checks. So I can write checks for, I don't know, a specific cluster, or I can write a test for another cluster, so I can put a different folder. So ReFrame allows you also to play around with these things. So these three command lines are, I would vote as the most important ones because allow us to migrate the tests or migrate our workflow to different systems. And one thing that we do a lot is trying to separate or report to the users the different steps, right? Because when you're compiling the code, you have to compile it in an isolated place so that it doesn't scramble your home folder. For instance, you're running on a home folder in your Scratch. So we actually go into different folder, and if it fails, it's good that you keep the files there, keep the scripts that we have generated there to run them, so that we can try to reproduce. So we have and if it passes, maybe my Gramax input file is like 1 terabyte, 1 gigabyte, and I don't want to save it to the output. So you may choose also to store some files or don't store some files after the test has passed. So we have the separations of concerns. So we have the stage directory where your test runs, the output directory where you actually save your selected files that you really want to save for your test, and we have this performance log directory. If you have chosen to write a performant test, which means you chose to have analysis of the performance, then you can also save a log of the performance. You can say, well, but why that? I mean, why? Well, in a production system, like we do in PitchDyn, we do production runs, which means we run ReFrame every single day. So we save on the same folder always the tests. So now we have this file that per test, right? We have one file per test that contains the performance of the applications along the days, right? We have the date, we have the time it was run, so we can actually do statistics. That's what we do on PitchDyn at least. So how does it look like when you run it? You get like a Google test, some sort of output that you say run, okay, or run failed. And when it failed, and then you're gonna get failed, and the reason why, oh, this guy failed and on the performance phase, right? So you know that the performance didn't match, and the performance reference was 70, but it didn't fall within so the reference was 70, and the value that actually was getting was 50, so it didn't fall within the range that you wanted. Because I didn't say that, but we can also say a range, because we're dealing with production systems, right? So they fluctuate the performance. If I get nodes that are really local, I'm gonna get a better network performance, but my nodes are all spread on the system. My network will be not that good if I don't have a fully connected system, right? So, and one thing that I like a lot is this logging. So this is how the log file looks like. But because we also send to gray log, right? We can make Grafana graphs. So I mean, we can make graphs out of this performance. So every day, the guy who's on roster has to look at the performance, see what had failed and didn't fail, so we can actually get these statistics and know, you know, things have fluctuated or didn't fluctuate the performance. So how do we actually use? How do you leverage all these things at CSCS, right? So we do have around 241 tests, so which means that we have 241 files with different test cases. So this thing spawns into different test cases. What's the test case? It's the combination between different program environments, different variables that you have produced with parameterized your tests. So we have like just 241 files more or less, and then this spawns into, I think, 1,000 tests, if I'm not mistaken, by test cases. Yeah, but I think today is around 1,000, something like that. So it really spawns several tests. Of course, we don't run 1,000 tests because they're split into different systems, you see here. But that's how it looks like on Pitchline today. So we do have what's called production. So we run daily these tests and the maintenance for the maintenance when you have maintenance, and we do also for node diagnosis. And it's nice to have a production run, but if someone has to be in charge of running that, it's not so reliable. So what we do, we have Jenkins running our production systems every day. So we have Jenkins slaves installed in our clusters, and every day in the production, ReFrame is executed. So which gives us really good statistics, because we have not only the performance log that we told you, but we can also know if the test failed, what's the meaning, right? If my hello world has a performance failure, and in our case, hello world means that performance failure in hello world means that you took more than 60 seconds to compile hello world. That it's a really good indicative that we have a huge file system issue, right? So because we was not able to read hello world to a simple file. So we can kind of try to guess. So we have network tests, we have I/O tests, we have performance tests into our system. And you may think, okay, this is a bit like overkilling, right? Yeah, but once operations was did the maintenance on the cluster, and the cluster was supposed to be, the GCC was supposed to be emitting hardware instructions, and suddenly stops emitting hardware instructions because they just forgot to install something else in the system, and then we detected it and we told them, and then they suddenly start to go back again, right? So it's really important to guarantee quality of service to be running these frequently. So this is more or less how it looks like for us. We have a pipeline to do, for instance, in this case, a cache production system, and then we open the open blue ocean, and you see how the pollution look like, and then you look at all the failures for that day, and you can see what has passed or what doesn't pass. So this is nice, this is great, but it doesn't cover all my problems. As a support guy, I have to give other versions of Gromax because the users ask for other versions, right? So whenever I am compiling a new version of Gromax, what I do, I have to take the recipe that I have for Gromax, change the version, compile again with EasyBuild, and run ReFrame, right? ReFrame allows me to change the modules and everything. But wouldn't it be better if I can run EasyBuild directly and get ReFrame running my test, because I do have a Gromax test? So that's what we want. We want to integrate ReFrame with EasyBuild, right? So the integration that we have a proof of concept integration we want to propose, allows us to optimize or optatively, or you can choose to run this integration or not. And why? Because sometimes you do need it, sometimes we don't. Let me say one case. We do provide EasyBuild recipes to the users, right? The user may install that version of EasyBuild, but he doesn't want to test my test, right? He wants to test his input file. So in that case, he will compile Gromax and then test for himself his input case, right? He doesn't have to waste his compute resources with my test, right? So For him, it's not so nice to be using this. So you can option to use it. And some, for instance, like we have some tests that are MPI based, and some systems you cannot run MPI locally. So also that may not be optimal for you. So what we have done is basically we have leveraged EasyBuild hooks as proof of concept to integrate ReFrame, and we have seen really good advantage of doing that. The advantage is because you're doing hooks, you are actually inside the easy block of ReFrame of EasyBuild, so I can leverage the entire EasyBuild infrastructure. That's really good. So I can program completely what I want, and I don't need to change ReFrame, right? That's easy. So I just go and call ReFrame and I run ReFrame. The bad thing about that is that to actually support the easy block, you need to APIs from EasyBuild, internal APIs from EasyBuild, which may or may not be available in the next release, right? So you're gonna break. And these things are not unit tested, right? So these hooks are not unit tested. So whenever you do a release of ReFrame or EasyBuild, they didn't see this code, so they didn't unit test it, right? They didn't check if it's properly running. And another thing that's really interesting is that because I'm running the internals API, which are tied to a version of EasyBuild, I also have to come with like command line arguments for ReFrame, right? -R, -C, capital C, all this kind of stuff. So it binds also to the version of ReFrame I'm using, because if I change the command lines argument of ReFrame, then suddenly I'm not being able to use that feature, because you cannot pass command line argument to hooks on EasyBuild, right? So what we really want is that instead of having just a hook, this integration becomes a full step into the EasyBuild pipeline. And to give an idea how this thing looks like, that's the integration, right? This is proof of concept of the integration. EasyBuild does not support a function called prepend fake modules path, right? What it does is load fake module. That's what it does. It does this prepend, and at the end just loads the module. So what I have to do, I have to remove the load command, make the function here, and put internally to this post hook, because the API is not there, right? The function is not there. Why? Because whenever you install the software, you want to prepend the path, so I can actually load that path when I'm running ReFrame, right? And then you can see things like if not dry run, right? Oops, hooks are executed if you have extended dry run, right? This is really nice. I was talking to Kenneth yesterday. He said maybe a bug. I said no, this is a really nice bug. It's a feature. Why? Because I can now see when it's dry run, and I can say, oh, ReFrame command was this one, right? So I can do proper messages when you are in dry run mode, so extended mode. But it implies that I have to include a lot of things from EasyBuild. For instance, at VSC utils, like he was talking yesterday, will disappear in EasyBuild 4. So this is doomed to be broken, right? So we do need this step to be integrated. So how does this integration look like today? I mean, this is even a simple case, right? Because you see, there's some things like if I am doing GrowMax, then call the test for GrowMax. If I'm doing Amber and CUDA, do these other tests for Amber for CUDA, right? But wait a second. This is the tests that I have for ReFrame, but it may change. But this is tightly integrated in the hook. So if whenever I update or add a new test to ReFrame, I have to come here and update this table. And if you go to this production file, you're gonna see this if is not just this is small. This is just enormous. It just takes the majority part of the function. So this is not optimal integration. Another thing that's really interesting is that because hooks cannot be passed command lines, I actually have to hijack the build options import the build options. And to do dry run, I have to know that there is also the silent option, right? If EasyBuild changes tomorrow, the command line doesn't require silent, this is broken, right? So I think I have been stressed enough that this is not a good solution, right? We need a proper integration. And how does it look like to run today? I do hooks, ReFrame, and then runs, and then run post sanity check hook. And that thing actually runs ReFrame. So, and the output looks like that. Running Amber, and then doing the checking, run the Amber GPU, because that one the GPU version, and ReFrame was executed. So let me review just a bit. we did the normal sanity checking of Umber, so that comes with EasyBuild. And additionally, after doing that, which means that I guarantee that I have the binaries installed, blah, 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 I can now run the regression, right? I can run. This step I would do, but I would do like a monkey, right? I would run this. After it was run, I would go there and run ReFrame myself. So I'm just putting the monkey step that I was doing into integrating into EasyBuild, right? So, but what we actually want is something like that. We want something like minus regression framework, and you can choose ReFrame, or you can choose UB2, or you can choose build test, or whatever you want, and then give additional arguments. Because if I'm running on my laptop, I may not be able to detect it because my DNS changes if I'm on CSCS, I'm at home and everything. So I may want to give like a different command line option to detect my system or anything like that. And then the integration that we want is that then it becomes a full step in the pipeline, right? I think I'm running a bit out of time, but that's really good because with that we finished the integration step, and I just want to acknowledge the people who actually have actively contributed. So as you can see, it's a lot of people with big salaries working every day on ReFrame. So we do have a lot of efforts on ReFrame. So if you're feeling that ReFrame has no future, it'll be dropped or anything, no, we invest a lot of money on that. So it's going to continue. So it's a really safe project to catch up. And to give you some directions of what we have been doing with ReFrame is that ReFrame now does not support what you call dependency. So we could have something like my test compiles, and then my other test compiles something, my other test compiles something, and then I have like this multitude of run tests that will depend on these compilations, right? We don't support that. That's something we want to do. We want to get some dependencies. So let's say this test depends on that other. So if that guy fails, I won't run all that. So we want to have a better container support. We do have containers. We can run containers inside ReFrame. Not a problem, but for us it's all about the user story, right? So you want the user story, the guy who's writing a test written in container, to be as simple as possible, right? So we are improving our container support, and we want something like a benchmarking mode where the output, the summary is a bit different, when it gives you a bit more benchmark details. So my final message, or my take-home message, is that ReFrame is, you can write in high-level Python your tests to do regression tests that can encompass from your laptop to a supercomputer system, and it gives you comprehensive outputs, comprehensive reports that you can integrate with your Graylog infrastructure, your logging infrastructure, and it's let's say, as an extra point here, it's highly maintainable, and CSCS has big future for that. So with that, thank you very much, and questions?
Thank you very much, Victor. Any questions?
So it's
working. Yeah.
It's mainly a curiosity. I was thinking, what were the design thought that led you to list as key feature we have no dependencies on whatsoever?
Yeah, okay.
And the second one may be related. How do you store historical test data?
How do I install or store?
Store.
Okay.
Yeah.
So can I answer for the second, then I go to the first one? So for the historical data, we do have three things. The first thing is that we do save the log files on a shared file system. So whenever you run on a Bitsnight, on cache, or other system like Only, for instance, that we showed here, all the logs will be saved on that thing. So on that parallel file system, and saved in specific folders per system. So I can keep track of all of those log files. The second thing we do is that we have a log infrastructure for centralized infrastructure in CSCS for logging, Graylog infrastructure. So we send the data to this Graylog, and then we can probe these data into Graylog directly, or you can do the third one that I showed here. We can get the graphs of these data to a Grafana, right? So that's we say this is a Grafana, the access gray log. So we do as infrastructure itself, file system, and or a gray log system, a logging system we support. So for the first question, why we don't want to have independency? Well, because installing Python for some users is a bit difficult thing, right? So some people don't want to have like a bloated Python, or some versions of operation system like Red Hat 7 comes with setup tools at 0.9 point something, and if you do update the setup tools is 44 or something. So we don't want to be bound by this versioning also of the dependencies, right? We want to guarantee that we run independently, and if there's a bug in one of these dependencies, then we have to update it and guarantee that the version, and then my user have to update it. So you don't want to have anything related to upgrading. And Vasilis may.
So another reason is that a key thing is to run the test in the user in an environment that's as close as possible to the user. So even now, when you run ReFrame, you don't do any module purge. You start from the environment you are currently in, and optionally you even unload the module that has loaded ReFrame. So if you even unload the module that you have loaded ReFrame, and you had lots of dependencies that perhaps has changed, I don't know, compilers or whatever, change basically the environment that the user test will run. So if you, in order to run ReFrame, you had a set of dependencies installed, then perhaps that could be a problem. Wouldn't replicate exactly what the users do when they log in. It's a clean environment. We wanted the environment to be as clean as possible. But yeah, it's not a strict mandate, but since we can still keep it, we do have a PyTest dependency, of course, but it's only if you want to run the unit tests.
Any other questions?
Do you have a repository somewhere where you can share tests with other people?
Yeah. So on the repository, actually on the ReFrame repository, you have a folder that's called CSCS tests. So you can take a look at all of the tests that we provide. For instance, like Gromax tests, you can see how it's written, but you actually don't have the input files. So you cannot run exactly the Gromax we have there because you don't have the input files. But you do see the tests, right? But other cases like Hello World, you have the files. Like any video test, you have the files. Network test, you have the files. But because of the size of the input files, sometimes we didn't put on our Git repository. But just a question of the size, because we didn't want the people to go git clone and take forever cloning the ReFrame, right? That's one of the ideas behind. We're investigating to do Git LFS, right? Large file support, like large file system, but it's still being investigated. So we haven't come up with a solution yet that we can share tests. But we're investing a lot now on sharing our tests and get people sharing their tests, because we from those stargazers and people that actually have forked the test. So many of them are supercomputer centers, so they do have the set of tests, right? And it would be nice that they share with us and we share with them, and then people can download from their side also if they're willing to do that, right? So we are trying to find a way of how to share between sites. The same problem that EasyBuild has, that people have their own local repositories and want to share stuff, and yeah. But you can take all the CSCS tests.
I have a question as well.
Yep.
One of the things I've been struggling with in EasyBuild a bit is the regression testing. We've talked about this.
Yeah.
And I really want to look into ReFrame to run the EasyBuild regression test with ReFrame. So what would that mean? Do I just have to define a single Python module that instructs ReFrame how to run an EasyBuild test? Is that it, or? So if you want to do the API integration, right? Python to Python, or you want to do? It doesn't even have to be with the API. I'm happy to call the EB command from ReFrame as a command. For inside ReFrame, yeah, you can do that. You can actually write a test and say my build test would be. You shouldn't have to do the build test. Pre-build command will be EB, and then you're gonna get EB your file, and then that's it. You're gonna run, and you can parse the output. So we do support EasyBuild today. That's not. I mean, we also support Spark today,
but the user story is not optimal. So we don't say that we support it, but
And you support it how exactly? Like
so we do have this build system, right? And so I can say build system is single source, which means that we're gonna do nvcc on this file, right? So there will be a build command to do that, and the build command will be composed of these lines, nvcc and blah blah with -03, all this kind of stuff. But there's also a pre-build command, so you can self.prebuild command equal to something, and then you can say eb blah 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 you want, and then you're gonna do the eb command, and then it's gonna skip. I mean, you don't have to do the actual build, so the build will be none, and then that's it. You can just emit no build command. But this is, you see, this is, it feels like a hack, right? So this is not a really nice support. So we were thinking about how to leverage these into getting EasyBuild, because there's something we need to do with EasyBuild to make EasyBuild work out of the box, right? So, and that's what we are struggling with, because okay, the stage directory, I can point to the build directory, all this kind of stuff, but if my system is L-mod, does the guarantee that this EasyBuild will be, if my EasyBuild was misconfigured, will it work or not? Do I change the configuration to make it work, or do I take the configuration from the system itself? So these are things we are trying to answer ourselves before actually writing the full reply here. Or do I always pass the modules to command here to EasyBuild? So this is things that we are investigating, let's say, to see what's the best user story.
Final thing, yeah, I mean, coming back again to your question is mostly, I mean, we should see a bit the exact test case, what you want to run, because you can write a monolithic ReFrame test that does EB something, but remember talking with you about the dependencies. So yeah, let's see the exact test case, because in any case you can run, because essentially it will generate a script, so you can run whatever you like. Now it depends on how efficient, what exactly you want to do. Another thing, just to add on the users, actually, we have already from US several centers that they're trying it or actually using it. I know Ohio State Supercomputing Center is currently having in production. NERSC and LLNL, they have again in production. They run some tests, and then we have other centers as well. It's from universities, and also Rutgers University. We have, I mean, starting building up also community. So the idea is now how we start sharing tests. It's also the POSI Center in Australia, NIWA in New Zealand. I know they're running on production. There's also a couple of private companies in HPC that they're using also PBS backend, and they contributed this as well. So
yeah.
So we hope that it will expand more in that aspect.
Yeah. And if you want to do the integration of EasyBuild and ReFrame internally, we have to get EasyBuild to be Python 3. Right? That's the, but it's also possible to do that.
Any other questions? If not, yeah. Thank you very much, Victor.
Thank you.